turning point by completing square or by graph. Okay, and then sketching. How to sketch for a quadratic. To make the view better, how I can make a center in the middle, how I can view that. What else? How to define a equation. Define an equation. Okay, that's what I think that's all we need to talk about today. All right. So let's have a look at, just use the paper I gave you last Friday. Just use the question there. I think they are good questions to talk about. I'm not going to talk about today by how to do by hand approach. You should be able to do that because the coming test next Tuesday is doing by hand. Okay, it's not doing CAS. But the next application task will do it by CAS. So everything is rely on CAS. So that's the skill I will prepare for you for the next application task. Okay, so let's go one by one. How to find turning point? Okay, the first question asks you to identify the turning point of each of the following. Just start from the turning point. Okay, if we go to the calculator page, okay, one thing, okay, very, very important thing. Never use this A and B, the scratch pad. Okay, never use A and B. Anytime I see you use A and B, I will delete all your documents and needs to start again. Okay, so I'm not allowed you to use those two because I'll give you a reason. First of all, the setting here is not reflect in the scratch pad. So whatever you set up here is not going to show here. This is a really simple calculation. 1 + 1 = 2, something like that. You work by using that. It's a quick page and then you just start from that. Second reason you're not doing it is actually give you a wrong answer. I've missed quite a lot of times. Students bring the CAS to me. Miss, I'm typing exactly the same thing compared to what you type in, showing on the screen. Why I get a different answer? That's the question I have, and that's why they use Scratchpad. Okay, I see they use Scratchpad, exactly the same thing I checked so many times, and the answer is just wrong. I don't know why it's wrong. This is just not a good function to use, especially circular function. If you do circular function in the Scratchpad, everything's wrong. Okay, because the setting, the degree, the radian doesn't hold in A and B, so that's why it's not working, and the graph can be a mess. Can't sketch out anything or like sketch a wrong graph for you. So that's just a wrong function to use. Okay, so maybe simple calculation like 1 + 1 = 2 that can work, but not like the complex ones. So something you must remember now, because when you get your calculator, we're not teaching you, you start from A and B, and I see so many of you actually using Scratchpad, but that's something you shouldn't use. Okay, something you shouldn't use. Let's say I already opened the page before. Okay, I already opened a page, if you remember, like the calculator page. If I also go back to that page, what I can press from the home page is the current, the number 4. If you type number 4 there, it will go back to the current page, like whatever you're calculating before. When you go from that page to the home screen and then you type 4, it will back to this page for you. Okay, so for turning point, the first function we'll use is for turning point. Okay, what you will do is go for menu, algebra, and then there's something called complete the square. Okay, complete the square. So you type that in. You just click on that, you have complete the square. Well, very obvious function. What's doing completing square for you? You just type the function in. What we have now is x squared plus 16x plus 64. Yeah, x squared plus 16x plus 64. Well, better times the times sign in between all the values in case there's things, just keep this habit. I just let you know I don't need to time this times in this case, it still work. But say if you use the variable a and b, if you just go 16a, not 16 times a, the answer will be different. It will recognize 16a as a whole value, not recognize the a as a variable. So you need to be careful with that. Just keep the habit when you type things into the calculator. If it's times, make sure you press the times button. Okay, and then keep your expression like that. see the two field argument here. So what you're missing is telling the calculator what is the variable. So you know when you solve, solve for x, comma x. So in this case, you solve, sorry, not wrong place. The comma x should be in the bracket. Okay, the comma x should be in the bracket. So comma x means the variable in this case is x. And if you press enter, that will complete the square for you, is x plus 8 squared. And you can see turning point is minus 8, comma 0 in this case. Why I need to press the comma x? You will say, oh, there's only one variable. Why I need to do that? I'll just show you something interesting. If I change this to a, okay, I don't have 16 there, but I have a there. What's a? A is a number. What's the size? I don't know what's the size of a. A is just a number. If I just times a there, and I say comma x, it means x is the variable. Then anything else other than x will be numbers. Okay, so x is your variable. Then anything else will be your numbers. So when you press enter, it will complete square for you as well. So completing the square, I have x plus a over 2 squared. And then that's the constant, a squared over 4 plus 64. They're all constant. So the turning point in this case is minus a over 2, x value, and y value is everything here. Not there. Everything here. That's the y value. So the x value of the turning point is minus a over 2, comma of that y value. So why I need the comma x? Because I will tell the calculator what is the variable and what are the values. So a is the values, x is the variable in this case. So therefore it will complete a square for you like this. All right, so that's for the first one. Okay, that's for the first one. What else I will have is just tick what I have. Okay, I have done this one, completing square by finding the turning point. Now I want to find for x-intercept. Okay, before I find x-intercept, what I want to do is teach you how to define a function. If you look at page 1, question 7. Okay, if you look at page 1, question 7, minus x squared plus 8x minus 20. Okay, for that function, minus x squared plus 8x minus 20. Okay, for this one, I want to define it. I want to give it a name. Well, we haven't learned what is fx yet. You may guess fx is just y. Y is fx. So what is fx means? Just give you a simple explanation. Fx means the function's name is f. Well, instead of y, the function's name is f. And then x is what? X is the variable. X is the variable. What is the changing value? X is the changing value. So how I can define, say, page 1, question 7? I can type the function in. The function is minus x squared plus 8x minus 20. Okay, type whatever you have for the function. Fx equals to what? Equals to that. Type that in. And what's the next step I'll do to define it? I want to give this function a name. So I will press Control, okay, the Control, and then the VAR. Okay, the VAR is the button above 9. To have this arrow here, press Control first and then VAR second. Okay, Control and then VAR to have this arrow here. This arrow means defined. Okay, this function is what? Is fx. Okay, what's fx? Name is f. Your variable is x. You can change x equals to what in this bracket. For example, I want to see what x equals to 0, what's the y value? When x equals to 1, what's the y value? I can change that. But anyway, we type that in first. The name not only can be f, it can be y bracket x, can be c bracket x, can be h bracket x, whatever you like. Just give a name and then bracket variable. Bracket x, what's the thing you can change in this function? It is x. And press enter. You will see done, like finish define that. Okay, that's a done. Okay, I finish that. And then let's find y-intercept. How do we find y-intercept? when x equals to 0, right? So what I can do is f bracket. Can you see it's a color, like it's a dark, it's different from this one now. It's already been defined. It's something already with some function in it. It will show like this. So f x equals to 0 is the y-intercept, right? You just put f0 in. You just put f0 in. Just make it higher for you. Okay, you define the function, and if you press f0, you will show, you be given for the y-intercept. That's negative 20. Say I want to substitute another point. What I can do is f, for example, 5. I want to see when x equals to 5, what's the y value? I can just type f bracket 5. And I can see the y value for f5 is negative 5. So why I want to define the function? Because it's convenient to substitute. If I don't define this, what I need to do, I need to sub 5 in here, 5 here. And then I also change another value. I need to go, for example, 10. I need to change, okay, minus 10 squared plus 8 times 10 minus 20. I need to time more things. And I think the equation, if it's even complex, the coefficient is not integer numbers. I need to times like very complex things again and again and again when we're trying to substitute value. So why I define it is easy. Fx is exactly the same thing as minus x squared plus 8x minus 20. So every time you type fx is same as you type that. Okay, same as you type that. So that's my define. Okay, how to define the function. I have done that. How to find y-intercept. You can sub 0 in. Well, how to sub f bracket 0. Okay, f bracket 0. So that's how we sub values in. So first defined and then put f0 in. Yeah, that's done. Okay, x-intercept. How do we find x-intercept? How do we find x-intercept? Make y equals to 0. I can go menu number 3. And then number 1 for solve. Okay, menu 3-1 for solve. Okay, menu 3-1, we type the solve. Okay, what we want to solve? We want to solve that function equals to 0. Remember that function, I have defined it. The name is fx. The name is fx. So that function equals to 0. Okay, so something equals to 0. Then comma x. Okay, fx equals to 0. What's my fx? My fx is minus x squared plus 8x minus 20. I defined in the previous line. So I will make fx equals to 0. Fx bracket, finish the bracket, equals to 0. And in the big bracket of the solve, I put comma x. So comma x needs to be in the bracket. What means by false? False means what? I'm not doing anything wrong. So if I have false, what that means? There's no x-intercept. Okay, there's no x-intercept. I cannot solve out anything. There's no x-intercept. Let's find something with x-intercept. Let's look at question 5. X squared minus 2x minus 3. So menu 3-1 to solve. X squared minus 2x minus 3 equals to 0, comma x. You can see that's how you can find that. And then you want to find the y value or y0 because you already make y equals to 0 to solve for the x-intercept. Or the other function, if this is a general solve, any equation you want to solve, you can use menu 3-1 to solve. But if you just want to solve for x-intercept, I think there's another place you can do it. Well, I never really use it, but you can solve for zeros. This means y equals to 0. And then I can just type this function in. And then comma x. You have the same thing. X equals to -1 and 3. So that gives you the same result. It's menu number 3 and for number 4, zeros. Menu number 3, algebra, and number 4, zeros. And the only thing you don't need to type is equals to 0. Compared to those two, solve is you must type the equation and then comma 0. For 0 means y equals to 0. We assume that already. So this function equals to 0. And then you don't need to write 0 equals to that function. Instead, we directly write comma x. You just save a little bit energy, like 2 button equal and 0. But they are the same thing. You get the same result. X equals to -1 and x equals to and 3. All right. That's the x-intercept done. What else I want to do? I want to sketch. Okay, number 5, 6, 7, 6, 7, 8. You choose one. Which one wants to go through to sketch? 6, 7, 8. Pick one. Go for 7. Okay. If you go for 7, do you remember my 7 is already been defined? This is my function. It's stored already. It's called fx. This minus 8x plus 8x minus 20 is fx, like with a name. Well, you can type it again. It doesn't really matter. But like to save you some time, I can just use fx instead of the minus x squared plus 8x minus 20. Okay, so if we go down here, we go back and we click on the second one, this graphing thing here. I can just put f bracket x here. Okay, remember, if give you this function to sketch, if give you a function like this, y equals to t squared plus t plus 1 to sketch. This is a quadratic as well, right? Your variable is t. On your graphing page, you cannot put t. You must change all your variable back to x. Because see, the function is already given is in terms of x. You cannot type any other variable other than x into this page. So you can't times t squared plus t plus 1 here. If you times that, it types that, that's wrong. Okay, that's not working. It won't show you any graph. So you must change all your variable. Like, you don't care about what they give you. They can give you t, they can give you a, but your variable must be x when you type in.
What happens if you have an unknown variable?
What do you mean by unknown variable?
Y
you can't sketch it.
Plus a.
Yeah, you can't sketch it.
Oh.
Like you must, it's a certain function. You must have a look. Because if a is a, well, what we can do is if a is an unknown variable, you can still type that in, and then that will create a slider for you. When you slide, just change the slider, the graph will change, because when you change your a value, everything will change, right? I'll just do for one example here. Let's go for ax squared plus 1. A times x squared plus 1. That's with an unknown value a here. My variable is x. It's already defined as x. It can't be anything else. So my a is an unknown value. When I press enter, it will ask me whether create a slider for a or not. Okay, so if I press cancel, then I can't sketch out anything. If I press enter here, it will create a slider here for me. Can you see this box? I can move it. I will have a box here. This is my a value. My a can take from what it given to us is -5 to 5. I can change it and like, but what we can hold the hand here. Wait.
Wait, does it just appear?
No, it will just appear. Can you see if I change my a value? My one can't really slide, but you can hold it to slide. Can you see if I change my a value? That's changing. Can you see this function is changing? Because a can be wider or thinner, and also can reflect it, can be downwards, like fatter or thinner, but like this is the slider, how slider works, because a is an unknown value. When you change your a value, the graph will look different. So that's how like a slider will work, but we don't need that really in year 10. Well, year 12 we don't really use a lot of that. You can try to use it to see some question, but not really that helpful. But anyway, let's go back to open a new page and also sketch my fx. So my f bracket x, I want to sketch my fx. There's no variables in it. There's no changing values in it. It's a fixed function. When I press enter, what you can see, your graph is not viewed better, right? It's not like a really with a good view. Okay, so what's going on here? What's going on here? The window, like you only see x value in between -10 to 10, and you only see your y value in between -6.76 to 6.67. Yes, you need to change where you want to look at it. Like this is not a good place to see the graph. Like a lot of graph is actually at the bottom here, right? A lot of graph is actually here, not there. Sometimes in some extreme case, I can't even see any graph. The graph just disappears. For example, if the graph is actually here, I can't view it. Okay, so a lot of students come to me and ask me, why I can't sketch anything? It's not you can't sketch out anything, it's your graph is not viewed within the given window. So we need to change the window settings to make the graph properly viewed. Well, this one is easy. I can still see turning point is approximately there, right? And then there's a lot of things down here. So I don't want a really, you can see my maximum is not even reached 0, but I have a lot of negative. So what I can do is I can go menu, number 4, window and zoom. Do not use zoom in, zoom out. That's not working well. Okay, and very slow. Just use a lot of time. I will go for number 1, window setting, menu 4.1 for window setting to change it manually. Then you may ask me what I should change. I will say analysis the graph first and have a good guess. Okay, a good guess. Well, my guess for this one is my maximum, well, x value is kind of alright. I'm not really worry about the x part, but I can't view the graph at the bottom, which means I need a more negative value for y. Let's say make a -40 for y. I don't know whether it's working or not, but I just put it there. Okay, and then I don't need a really high value for maximum. I can just put a 0 for my maximum because you can see I don't have even the turning point over the x-axis, so I can't see anything. So just type that in, and well, x value remain the same. I can change the window setting, change where I want to look at. Press enter. See, this graph is more centered and then showing more here. I can just drag it a little bit. And you can see it's not reaching the x-axis and it's more negative here. Unfortunately, there's no good functions for you to find the y-intercept on the graph, but you can easily find the y-intercept by substitute 0 into the calculator page to find it. Do not try to find y-intercept on the graphing page. It's not going to work. Okay, another thing what we're trying to do is how to find turning point by graphing. How to find turning point by graphing. Let's press menu. And there's all these things is under analysis graph. Okay, so it's analysis graph. And well, what kind of turning point is this one? It's a maximum turning point or minimum turning point? Maximum. So I will go for max. Okay, so it's a maximum turning point. This is a maximum place. Can you see a dashed line here? Where's my line? It's disappeared. Okay, can you see here? The line here? See this line? I can move it. You can change it by touch screen, like touch the middle here. You can go move left and the right. Well, my turning point is around this region, right? Around this region. So I will go to the left hand side of the, okay, make this dashed line to the left hand side of the turning point and click enter. Can you see the notation change? It becomes upper bound here, upper bound here. You need to keep going that way. See that? And then press enter again when you move to the right hand side. A very terrible thing here is, can you see this value is 4.00001 -4? This turning point is actually 4, -4. It gives a lot of unnecessary decimals and it won't show exact values. That's the disadvantage. You can roughly see where's your turning point, but you can't get exact values. If you really want to find turning point, I will recommend you to go completing square in the calculator page to see the turning point, not using graphing to look at it. If you just want to see where is it, then you can see where is it, like it's about 4, -4. And especially when it has decimal like 4.0000001, like something like this, it means it's 4. It's not going to be 4.0000001. So it's 4. I don't know why the calculator is behaving like this, but it's just not a good function to look at exact values. And also, if your turning point is a third, comma, 2/3, for example, if it's a third, comma, 2/3, it's not going to show you a third and 2/3. It's going to show you 0.33333, comma, 0.66667. Is in the graphing page. When you use analysis graph function, it's not going to give you exact values. That's the disadvantage of the graphing. Okay, advantage is quick. I can locate approximately where's the point quickly, but I can't see the exact. If I ask you to exact label that for me, you can't label it. You need to find another way to work that out and then label it. For example, if I want to see turning point, I will go for completing square function and see where's my turning point in the original function. Okay, well, this is not a good graph because I don't have the x-intercept, but like, okay, I'll do something else. I'll draw another linear. I want to draw another linear on this graph. Okay, on this graph. So I want to type another function in on this page. I will press tab, T-A-B, the tab. Don't do that. Press tab. Okay, so you will have the place you can type function again. So I also type a linear in. So let's put any linear. So I will go for half x times x minus 20, not 20, minus 45. Okay, just type that in. Press enter. Where's my linear? This, oh, sorry. Go tap again. If I type the function wrong, I go tap again and go up to change my function. I don't want 42. I want a -15. Remember the value wrong. Give a -15 here. Go tap and then go up to change the function. You can redo the function and then press enter. Okay, there's my function. That is not in a good window. Like the linear is there, but like it's not in a good window setting. I can't see it. I don't want to adjust the window again. But now I can see the graph. I can go tab, go up, and go to change the function. Okay, just redo the function, fix any part you need to fix. Okay. How many intersections are there between this quadratic and this linear? 2, right? 2 functions. So what I will do is find the intersection, approximate intersection. Okay, it's not going to be exact because I don't think it's in the exact form, like integer, like exact integer. So what I can do is menu, analyze the graph, and go for intersections. Okay, intersections. Press enter. Okay, can you see 2 intersections, right? I need to find 1 at each time. Okay, can you see my lower bound like this line? I need to find the intersection 1 at each time. So I will move this line to the left hand side or somewhere to the left hand side of the intersection and press enter. And then you have the second line move to the right hand side of the intersection and then press enter. So the coordinates is given here. But as I said, it's not going to be exact coordinates, it's just approximation coordinates. It can be a fraction, it can be a third. So it will be something straightforward. You know where is it, but you don't know what's the exact value of it. If you want to find the exact value, I need to go to the calculator page to calculate it. I will show you how to do it later. I'm going to find the other one. Menu, analyze the graph, and intersection. Okay, intersection here. Okay, go to the left, press enter, go to the right, press enter. I have the intersection here. I can read the value. If the question asks you give 2 decimal places for the intersection, you can do that easily. Okay, just read it and then copy the thing down. Okay, that's my point of intersection by CAS. What's the other thing I want to do is which graph I want to sketch? There's no x-intercept. Okay, I will write the equation down. Just go to the front page, and then I just click that again to get a new page. I want a new page to sketch a new graph. What I will sketch is a quarter. Well, it's not really a question from the page. It's a quarter times x squared minus x plus 1. Okay, I want to sketch that. But just a random function. Just times the function in. Press enter. I have that. No, don't want that. Tap. Go up. Go for -2. Okay, go for -2. Press enter. Okay, I want this function. It's a good function. I don't need to change the window setting. I see it quite nice. Okay, quite nice. So it's a quarter x squared minus x minus 2. Can you see this function? What's the name of this function? This function is called f4x. Okay, it's f4x. It's already stored. When you graph the thing, already give you the name. So the name of this function is f4x. You can remember that to use it in the calculator page. But let's do the x-intercept first. Okay, how do we find the x-intercept? If you go menu, analyze the graph. If you go zeros, that's the first one. Okay, go zeros, that's the first one. I can find 2 x-intercept, but I need to find one by one. Okay, go left, right. Do not cover 2 intersections at each time. So go left, enter, right, enter. I have that point. Well, it's not exact. You know it's not exact. Analyze graph, 0, left, right, have the other one. So I should have 2 points here. Okay, again, it's not exact, but I can see approximately where is it. Easy for me to sketch. How about if I want to go back to the calculator page? Okay, this function is called f4x. f4x, okay? Remember the name. What you want to do is the x-intercept for the f4x. All right. What I will do, I will first tell you how to jump back from 1.4 to 1.2. There are 2 ways we can do it. I can go Control and up to have all the windows here. You can see all these things you have done, like all the pages you open. Control up, that's all the page you open. And okay, I can see that's all the graphing page. And this one is the calculator page I want. I can go up to, no, I don't want that. Control. My one is not working easily. I can just go there and go up, highlight that, and then enter. Press enter to open that page. So go back to the calculator page. Or what I can do is I can go Control left and right to move it. Okay, Control left and right to move it. So Control right is moved to the next page. Control right is moved to the next page. Control left, Control left. When you have less page, you can go Control left and right to do it. Also, remember you can delete page as well. So if you go Control up and keep pressing the delete DEL button, like this button here, you just keep pressing it, it will delete all the document for you. So do not open 20 page and do not delete it. When you finish the question, 100% sure you write, and then you can delete it. If you open too many pages, it will slow down the speed of your calculator. So just be aware of that. So back to the calculator page. What I want to solve. Do you remember what I want to solve? F4x x-intercept, right? So I can go menu, algebra, and zeros. Okay, I can solve for x-intercept at zeros. The function, well, what's the function? The function is f4 bracket x. That's my function. Move this outside and then comma x. That's how I solve for that. It's the same as I type the function there and then comma x. Press enter. I have the exact value for the x. okay, is negative 2 root 3 plus 2 and 2 root 3 plus 2. That's the x-intercept for F4. Okay, that's the x-intercept for F4. Can you see they are matching, like they are all called zeros in the calculator page and the graphing page? So completing square and then finding turning point is kind of the same thing on both pages. So if I can go back to this page, okay, well, go control up and 1.4, go back to where we sketched this function here. Now I know where's the 2 x-intercept now and the exact coordinates for that. All right, I'm going to find one turning point. What kind of turning point is this one? Minimum. So menu, analyze the graph and go for minimum. Okay, I'm solving for minimum y value. So go for minimum. Again, the same thing. Turning point is here. Go left and go right. Well, this one is the exact value is 2, negative 3. It gives you 2, negative 3. So that's what you have for the turning point. If you go complete square, that would be the same. You can solve out the same thing. Okay. So what we have done in the calculator page, we have learned how to go forward to window zoom that to go to see a proper graph. If your graph is not shown on the window page, what you need to do is you need to adjust the window to make the graph visible or make the graph looks good. And what other things we have done is analyze the graph 1, 2, 3, 4. 1 is solve for x-intercept. Minimum, maximum is to find the minimum turning point or maximum turning point. And 4 is looking for two graphs, the intersection between two graphs. We don't need the rest, okay? We don't need the rest yet. So in the graph page, we have learned how to solve for it. Okay, one last thing we need to do is okay, just check that. Okay, we have learned sketching, we have point of intersections, we have used graph to do that. Okay, we have done all of this. One last thing to do is how to solve the point of intersection. Exact, okay, exact point of intersection. For example, I want to solve for point of intersection here, but exact, okay, exact. This is not exact. I want the exact values. Okay, we can just copy that function, two function. Okay, what's the name of the two functions? Have a look at your graph. What's the name of those two functions? On my case, F2 and F3, right? F2 and F3. So when I time F2, it will be the same as the F2 function, and when I time F3, that's the F3 function. So what I will do in the calculator page, I will go menu 3.1 to solve for something. Okay, if I make F2 equals to F3 and then comma X, I can only solve out X, right? Okay, think about this. If I go to show you the intersection question. Okay, just look at this question here. What we have done. We equalize the two functions, right? And then we solve for X. After we solve out the X value, what we'll do to find the coordinates? Sub X back, right? I need one more step to sub X back if it's a hand approach. So equalize them, solve them, sub the thing back, and then I need to do one more step. But if I have calculator, I can do the coordinates together. I can solve out the things together. So what I will do is I will press the button next to 9. Okay, right hand side of 9, there's a button. Okay, I want to press that. Which one I will select is the first row, second last one. Okay, first row, second last one, this one. Click on that. You have something like this. Just use which example? Let's use one example. Let's use this one. Okay, let's use this one, a complex one. Y equals to x squared plus 2x. Okay, the first one is that. So type that in. y equals to x squared plus 2 times x. Okay, that's my first equation. And second equation is 2x minus 3y equals to minus 4. 2x minus 3y equals to minus 4. Okay. Finish type the two functions, simultaneously solve them. And then, okay, can you see this is at the bottom line now, like what is the typing edit thing? Press right, okay, press right to make it move back to the center place. And then you will type comma x, comma y. So your variable is two things now. Two equations is good to solve for two variables. So comma x, comma y. Press enter. It will give you pair values. So the first pair, the coordinates, intersection coordinates is negative 2, 0. The second one is 2 on 3, 19 on 9. Okay, so the coordinates is negative 2, 0, 2 over 3, 16 over 9. Okay, that's how to read. That and that's one coordinate. Or is the next value, and then that's 2 over 3, 19 over 9. So that's the next coordinates. If there's more, it will be or another one. But the maximum is 2 intersection here. So that's how to use a calculator page to find intersection. Okay, to find the intersection between not only a linear and a quadratic. It can be quadratic and quadratic. It can be anything. Just type the two function in, comma x, comma y. It will give you the coordinates. All right, any questions? That's all the skills you need for the application task. Everything I said today, you need to be really quick doing it without thinking. Adjust the table, find the value, set up equations, define it. It's very helpful skills, okay? And also all the skills is very, very helpful in year 11. So I use the whole lesson to go through that with you. I hope you can try that by yourself, and you can check all your answers by using the function I teach you on CAS easily. Okay, so I don't need to provide the solution for you. You can check that with your CAS. So I want you to practice your CAS. That's what you need to do now for the next 15 minutes. Any other questions? No? Okay, good.